Salutations to all my students. Let's see this. Why a body moving in a circular path does not perform work? Kí ló dé tí object to move in a circular path does not perform work? That's strange. Oh, strange is here, Abi. Yes. Oh, yeah, strange. But let me show you. Before you can answer this question, you need the idea of, you need to know the difference between rotational motion, that's the first thing, rotational motion, and the circular motion. Circular motion. Ọ̀pọ̀lọpọ̀ students believe the rotational motion and circular motion are the same thing, and bẹ́ẹ̀ kọ́, they are different. You understand? When a body is moving, this is a body, and this body is assuming a curve, like it's assuming a, circular path. Let's say the body is moving a circular path, and let me trace out the directions of this body. The direction is this. Can you see? This is the body, and the body is going this way. Can you see that? The center of this circle produced by this body is right within the body. Exactly. Is right within the body. That is, the body produces the center of the circle. Anytime the center of the circle is produced by the body, we say the motion is a what? Rotational motion. But if a body is revolving round another body, let's say here is a what? Is a roundabout, and a body is here rotating round or moving round. You understand? Now, the center of this circle here is not owned. He say body learning. The center of this circle is owned by the circle itself, not the body. In that case, we say the motion of this body is a circular motion. So circular motion ó máa ń ṣẹlẹ̀ nígbà tí body tó ń move káàkiri circle yẹn kò ń sóun ló produce center of the circle. But in rotational, body yẹn ló perform, body tó ń perform circular motion yẹn òun ló produce the center of the circle. Do you understand? This one is rotational, while this one is circular. Do you understand the fact now? Now, sometimes o lè draw eléyìí síbí báyìí kò mean pé kó wà ń tà. You understand? IQ ló fi máa mọ̀ pé okay, this one produce the center, but this one does not produce the center. This is rotational, while this one is circular. Okay, let's see the rotation. Example of rotation, example of circular. If you talk about Earth, if the Earth is revolving around, the sun. What about that? The movement of the Earth around the sun. Here is the sun, here is the Earth. So the movement of the Earth around the sun, because this center here is owned by the sun, not the Earth. Therefore, if you want to say this, you say this one is a what? Circular motion. That is, the motion of the Earth around the sun is a circular motion. But when you talk about the motion of the sun itself, the motion of the sun itself is a rotational motion. Why? Because the center of the circle or the center of the axis, it's right within the sun. Do you understand? So that is the difference. I'm still going to talk about it properly. Okay, let's talk about this. When a body is revolving around, you understand? The first thing you need to know is the number one, the body does not cover any distance. Now, this is it. Take note of that. First, the body does what? Does not cover any distance. And kí ló dé tó sọ pé the body does not cover any distance? That body is rotating around the spot. Is rotating around the spot. It doesn't move. That's number one. Then number two that will give you a clear understanding is that anytime an object is moving around the circle, that body would definitely, have a centripetal acceleration and centripetal force. And the centripetal acceleration and force always at every point of the circle or at every point nínú circle yìí, the centripetal acceleration always directs the body into the center. Do you understand? And the body is about to move like this. Can you see the difference? If you look at the arrow, the acceleration, the centripetal acceleration or centripetal force is moving inward, but the body itself, in reality, is moving as if the body wants to go tangential to the what? To the circle. In this sense, the directions of this and the direction of the acceleration and the directions of the motion of the body are perpendicular. And when we're talking about work is done when the force and the distance are moving in the same direction. That is, the force that produces the distance is moving. That is, the distance is moving in the directions of the force that produces it. Don't say that the directions of the force and the direction of the motion of the body and the direction of the force that produces it are perpendicular. No, that's not. You understand? The direction must be what? Must be the same. That means if the force is going this way, therefore the distance should go this way. I hope you understand. So because of this, that means in this sense, the force times distance, remember work done is force times parallel distance. This is not a perpendicular. Take note of that. So because of this, we say the force here is equal to what? Is zero. Why? Because the directions of the force producing the distance is perpendicular to the directions of the body. Do you understand? And the directions of the force should be equal or should be in the same direction with the directions of the body. Do you understand that? So that's that. So the first reason is this, and the second reason is this. So they move in a perpendicular distance. Thank you very much.